When the James Webb Space Telescope turned its golden mirrors toward the mysterious interstellar object 3I Atlas, scientists expected to see the typical composition of a comet or asteroid. After all, most bodies that wander through our solar system are made of rock, ice, and dust. But what Webb uncovered was unlike anything humanity has ever witnessed in the cosmos. Instead of ordinary elements, the telescope picked up spectral signatures of metallic alloys, substances that should not exist naturally in the vacuum of space, and certainly not on a comet-like body. Even more shocking, some of these alloys are completely unknown to Earth science. The discovery immediately triggered waves of debate, speculation, and outright fear across the global scientific community. For decades, astronomers have studied interstellar objects that occasionally pass through our solar system, like the famous Oumuamua in 2017 and 2I Borisov in 2019. Both were mysterious in their own ways, but 3I Atlas has quickly become the most perplexing of them all. Unlike its predecessors, this object seems to be breaking every rule of planetary science. Its composition does not match asteroids, comets, or even exotic planetary fragments we've theorized about. Instead, it is giving off emissions that point toward alloys resembling engineered materials, substances normally forged inside furnaces, laboratories, and industrial foundries. The James Webb Telescope's infrared spectrometer picked up reflections and absorption lines that correspond to metallic bonds rather than simple elements. Think about that for a moment. When sunlight or starlight bounces off an object, astronomers can break down that light into a spectrum to identify which materials are present. Each element and compound leaves a unique fingerprint. What Webb detected on 3I Atlas was not the fingerprint of common metals like iron, nickel, or aluminum. Instead, it revealed blends that mimic alloys, combinations of metals fused together. And some of these fingerprints don't match anything known on Earth or in our catalog of natural cosmic materials. This poses a staggering question. How could an interstellar object wandering through space possess metallic alloys? Alloys typically require controlled environments to form. Melting points must be reached, temperatures must be managed, and materials need to be combined intentionally. In nature, alloys are rare and usually formed under extreme planetary conditions. Yet here we have an object from deep space emitting alloys that seem not only unusual, but in some cases impossible under natural conditions. Some scientists argue that we may be looking at the remains of an alien planet's core. If 3I Atlas is a fragment from a long-destroyed world, perhaps it contains exotic mixtures of metals formed in ways our solar system never produced. Others go further, suggesting that the presence of entirely unknown alloys could point to something far more unsettling: artificial construction. Could 3I Atlas be a relic of alien technology, drifting through the stars after the collapse of some distant civilization? Or worse, could it still be functioning, sending signals in a form we do not yet understand? What intensifies the mystery is that 3I Atlas isn't behaving like a simple rock. Its trajectory has already raised alarms among astronomers. Instead of passing cleanly through our solar system and heading back into interstellar space, it seems to be slowing slightly, shifting in ways not fully explained by gravity or solar radiation pressure. This unusual movement has fueled speculation that something more is at work here. Is the object being influenced by internal mechanisms? Could it be under some form of control? Or is it simply reacting to forces we have not yet discovered? The combination of unknown alloys and strange orbital behavior has drawn comparisons to Oumuamua, which also baffled scientists with its unusual acceleration. But where Oumuamua left us mostly with questions, 3I Atlas is delivering hard data, spectral fingerprints that shouldn't exist. Webb's instruments are too precise to dismiss these readings as error. The telescope has already proven its ability to detect faint atmospheres on distant exoplanets, spot molecules light years away, and resolve structures in the early universe. If it says there are unknown alloys on 3I Atlas, then the evidence must be taken seriously. Governments, too, are paying close attention. Reports suggest that space agencies and defense organizations have quietly convened behind closed doors to discuss the potential implications. If 3I Atlas is natural, It challenges our understanding of how matter forms and evolves in different parts of the galaxy. But if it is artificial, the consequences are staggering. That would mean, without a doubt, that humanity is no longer alone, and that we are now observing evidence of intelligent activity beyond Earth. The idea of alloys not existing on Earth should not be underestimated. Human civilization has developed alloys over millennia to advance technology, from bronze and steel to titanium and advanced composites. Each alloy was invented with purpose, to solve a problem or unlock a capability. When Webb detected alloys that don't match anything we know, it raised the terrifying possibility that some alien intelligence once designed materials far beyond our current technology. These unknown alloys could have properties we can't even imagine, strengths, conductivities, or resistances that make our strongest materials look primitive in comparison. As the data continues to pour in, the world waits for answers. Is 3I Atlas simply an extraordinary natural phenomenon, a fragment of alien geology from a world shaped under conditions far different from ours? Or is it a message in itself, a piece of technology traveling across the stars, carrying with it the signature of minds that mastered materials beyond our reach? The James Webb Space Telescope has opened the door to a mystery that may redefine humanity's place in the universe. To understand why this discovery is so shocking, we need to revisit what alloys actually are and why they matter. On Earth, alloys are deliberately engineered by humans to achieve specific goals. Bronze, for example, was humanity's first major alloy, combining copper and tin to create a metal stronger than either element on its own. Steel, an alloy of iron and carbon, became the backbone of modern civilization, shaping skyscrapers, bridges, and machines. Today, advanced alloys allow us to build jet engines, spacecraft, and electronics. They are symbols of technological mastery. In nature, pure metals are relatively common: iron from asteroids, gold in Earth's crust, or nickel in planetary cores. But alloys are rare because they require controlled conditions. To form them naturally, metals must melt, mix in precise proportions, and then cool under the right circumstances. This can happen in extreme planetary environments, such as the crushing pressures of a giant planet's core or during cataclysmic events like the collision of stars. But the alloys Webb detected on 3I Atlas don't fit those patterns. They don't match the geological processes we understand. Instead, they suggest something either completely alien to our science or something crafted with purpose. The James Webb Space Telescope used its near-infrared spectrograph to detect the composition of the gases and dust surrounding 3I Atlas as it approached the inner solar system. Normally, comets release water vapor, carbon dioxide, and dust grains of silicates or metals. But Webb picked up strange absorption lines that matched neither pure metals nor simple compounds. Instead, the patterns were consistent with bonded metallic structures, as if multiple metals had been combined into stable crystalline forms. What's more, the ratios didn't line up with any known alloy recipes from Earth. They were entirely new combinations, some with no theoretical basis in terrestrial chemistry. This has led to two dominant theories among scientists. The first is that 3I Atlas may have originated in a planetary system very different from ours. If its parent planet had unique conditions, higher pressures, different chemical abundances, or exposure to unusual cosmic radiation, it's possible that natural processes forged alloys we've never seen before. In this scenario, the object would be a fragment from a destroyed planet or moon, cast into interstellar space by gravitational interactions and eventually finding its way into our solar system. The second theory, however, is far more provocative. It suggests that the alloys might not be natural at all. Instead, they could be remnants of technology left behind by an advanced civilization. If 3I Atlas is not just a piece of rock but instead part of a spacecraft, probe, or artificial structure, then the exotic alloys might be evidence of deliberate engineering. After all, if humans design alloys for strength and utility, why wouldn't an alien species do the same, perhaps with far greater sophistication? Adding fuel to this theory is the fact that 3I Atlas is releasing these materials into space, almost like exhaust or emissions. As it draws closer to the sun, the heating causes it to vent gases and particles. But mixed in with the expected volatiles are these metallic signatures. Some researchers propose that this could be residue from machinery or structures embedded within the object. Others speculate it might be an intentional release, a kind of signal or byproduct of an advanced energy system we can't yet comprehend. The possibility of alien technology naturally raises more questions than answers. If 3I Atlas is artificial, how old is it? Did it originate billions of years ago, drifting through the galaxy long before humans even walked the Earth? Or is it recent, possibly even operational, passing through our solar system on some unknown mission? And if it is technology, what purpose does it serve? Exploration? Communication? Observation? Or something more ominous? These questions are no longer confined to science fiction. They are now the subject of intense debate among astronomers, physicists, and even national security agencies. Reports have surfaced of classified discussions within major space organizations about the potential implications. Some experts worry that revealing too much to the public could trigger panic, especially given the alloy's implications of intelligence beyond Earth. Others argue that transparency is essential. If humanity is truly not alone, we deserve to know. One thing is certain: 3I Atlas has already forced us to confront the limitations of our knowledge. When Oumuamua passed through the solar system, scientists debated endlessly about whether it was a comet, an asteroid, or something else entirely. Its strange acceleration and cigar-like shape fueled speculation of alien origins, but no definitive proof was found. 3I Atlas, on the other hand, is leaving a trail of data that cannot be easily dismissed. Metallic alloys that don't exist on Earth are tangible evidence that demands explanation. What's especially unnerving is that these alloys don't just fail to match Earth's metals. They seem optimized, almost too perfect in their composition. Some appear to have properties that suggest ultra-high resistance to heat, others incredible strength-to-weight ratios. These are qualities we strive for in aerospace engineering. Yet here they are, drifting from a mysterious interstellar object, as if casually demonstrating capabilities beyond our reach. As Webb continues to study 3I Atlas, scientists are racing to model the possible structures these alloys could form. Could they be remnants of a protective shell? Fragments of a propulsion system? Or simply minerals from a world with chemistry utterly foreign to us? Every answer seems to lead to more questions. The alloys may not just expand our understanding of the cosmos, they may force us to rethink the very boundaries of natural science. For the first time in history, we may be looking at materials that prove intelligence beyond Earth. And if that is true, then 3I Atlas is not just a wandering interstellar visitor, it is evidence. Evidence that humanity is being watched, tested, or perhaps even contacted in ways we cannot yet comprehend. The discovery of exotic alloys on 3I Atlas also forces us to ask an even deeper question. What if this object is not a fragment or wreckage at all, but something still functioning? The release of materials might not be a byproduct of decay, but rather the operation of a mechanism, perhaps one we cannot yet recognize as technology. If an alien species has mastered alloys we cannot replicate, then their engineering capabilities may extend far beyond anything humanity has achieved. They may have crafted vessels or probes capable of enduring journeys across interstellar distances without degradation, with materials designed to withstand cosmic radiation, micrometeorite impacts, and the gravitational stresses of star systems. Consider how humanity has used spacecraft like Voyager to explore the outer planets. Those probes were made with alloys designed to last decades in space. Now imagine a civilization millions of years ahead of us. They would not only have superior alloys, but entire technologies that appear impossible from our perspective. 3I Atlas could be a probe designed to mimic natural comets, blending in until it drifts close enough to a star system to gather data. The alloys Webb has detected could be the faint trace of that hidden purpose. But if this is true, the implications are staggering. It would mean we are not simply observing an interstellar rock. We are interacting, however passively, with a piece of alien design. And if this is design, it raises a question humanity has never faced. Did they intend for us to notice? Or are we merely stumbling upon something never meant to be seen? Skeptics argue that extraordinary claims require extraordinary evidence. They point out that unusual chemistry does not necessarily mean alien technology. Our understanding of planetary science is still evolving. There could be natural pathways to forming alloys in extreme conditions we have not yet witnessed. Perhaps in the cores of massive planets orbiting stars with unusual elemental distributions, exotic metals could bond in ways unfamiliar to us. In this scenario, 3I Atlas is a geological relic, not a technological artifact. Yet even this natural explanation is profound. It would expand the boundaries of what we know about the diversity of matter in the galaxy. The problem is that the unknown alloys don't just challenge our science, they break it. Their stability at observed temperatures, their spectral properties, and the ratios in which they appear do not fit into our models of planetary formation. If this is nature, it is nature behaving in ways entirely alien to our solar system. And if it is not nature, then the only remaining explanation is intelligence. Governments are quietly preparing for both possibilities. Leaks suggest that telescopes and observatories worldwide have been ordered to gather as much data as possible before 3I Atlas leaves our neighborhood forever. At the same time, some agencies are considering what it would mean to acknowledge the possibility of artificiality. The public response to alien evidence is unpredictable. Some would welcome it with wonder and hope, while others might respond with fear or hostility. The alloys may be just the beginning of a conversation humanity is not ready to have. Meanwhile, the James Webb Space Telescope continues its watch. Every new observation sharpens the puzzle. More data on the object's trajectory, more on the composition of its emissions, and more on the strange alloys drifting from its surface. Each measurement feels like a breadcrumb, leading us toward a truth larger than ourselves. Perhaps one day, humanity will develop spacecraft capable of intercepting such interstellar visitors. For now, we can only observe from afar, piecing together fragments of information as best we can. But the presence of unknown alloys in 3I Atlas will not be forgotten. Even if this object vanishes into the blackness of space, it will leave behind a legacy, a mystery that drives us to look harder, question deeper, and confront the possibility that we are not the first intelligence to chart the stars. In the end, the James Webb Telescope has not only revealed strange light patterns and spectral fingerprints. It has revealed something far greater, the realization that the universe is filled with possibilities we cannot yet comprehend. Whether 3I Atlas is a natural marvel of cosmic chemistry or the drifting artifact of an alien mind, it has already changed our understanding of reality. It forces us to accept that the unknown is not far away in distant galaxies. It has entered our solar system, passing silently among our planets, carrying secrets forged beyond the limits of human imagination. And as it drifts back into the vast ocean of interstellar space, one thing becomes clear: humanity has glimpsed the extraordinary. Alloys that do not exist on Earth are now part of our story. They are a reminder that the universe is far stranger, far richer, and perhaps far more populated than we ever dared believe.